Hello class, Dr. Mike here with CIS-1107. This is chapter 10, and we are looking at the week 14 content of connecting desktops and laptops to networks. So this is sort of really a summary chapter. It's going to just give you a few basics about networking and cover some aspects of it. We will look at the details for the lab also. So I have NetLab running here. We will come back to that in a second. First off, before we talk about actually configuring a computer for TCP/IP, connecting to the internet, which we've all done already. I'm almost positive every student in this class and all my classes at least connected some kind of device, a mobile device, a phone, a tablet, laptop, desktop. Most of the time it's pretty straightforward and it's very easy, but we're going to look under the hood of the details of how it connects. And let's look at some tools we can use. So before we actually look at this and start talking about the first thing called protocols, let's do a quick look at what is the internet. So where it all began, early 60s I believe, don't quote me on that, we have something called the Arpanet. Now Arpanet actually was a defense research now called DARPA. Early Arpanet was advanced research into networking, and they wanted to look at a way to connect, military wanted to look at a way to connect, example, Air Force bases here, like Eglin and so on, Gunter, down to the Pentagon, and to Hawaii, Moffett Field, that's over in California. And look, there's Wright Pat. So they want to find a way to connect these together. And this really came about from the Cold War we had with the previous Soviet Union. And the idea is routing. So if something was to happen here, this is Colorado here, it looks like it's a miner I believe. So they drop a nuke here, and this gets nuked. Traffic can still go from the Pentagon. Can't go here, so it'll actually reroute through Eglin to Gunter and across. If this all gets nuked, then again, we can route different ways. Now this is a pretty big effort at the time, and it was not something they can easily undertake, so they had to enlist the use of large universities and institutions. Carnegie Mellon University, for example, Stanford over here on the West Coast, NYU, Rutgers. You can see these different universities became part of the mix. MIT. They had the actual infrastructure, the computers, to help put this together. And so this is really the backbone of how our current World Wide Web works. Now this is the Arpanet. This is a lot different now. Now this was built upon and used by, of course, many people, but one of them being history of the web itself. So Sir Tim Berners-Lee, or Berners-Lee at the time, worked at a place called CERN. By the way, if you're a physics geek, CERN is like awesome. So I am. It's a particle laboratory in Geneva, and he ran across. They were using ARPANET type technology, as we know, is routing, and the basics of TCP/IP, which we'll talk about here, and also what that is. But he discovered that in 1989, you have tens of thousands of scientists from thousands of institutions from hundreds of countries, all collaborating in one place in Switzerland. And the problem was, when they shared information, there was no clear way to share formats. So one research institution used a certain format of a document, or their data sets were in different formats. You would read the paper and the research, but you could not maybe reference it, maybe you couldn't even read it. And so it's hard to share stuff across the network. And so this diagram here, it's really tiny here, it looks like. His first CERN diagram here, and he was a computer scientist at CERN, and he's like, we need a way to go ahead and share information across the network. And he came up with something called HTML, also called URIs, which we know as URLs now. So these two things together, he said, we can actually publish a paper, and then in there I could create an app that could read this, a worldwideweb.app, which was the first web server, which went to HTTPD. which is R. Now we know it's Apache. So using this technology and these two formats with URIs and HTMLs, you created a way for them to connect all the research together. So I could read over this network a page, as you call it, a web page, and then link to with a universal resource locator URL. I can get to anything on the network, including research, further research, whatever they were doing at CERN there. So you can say this was really a huge moment. This is actually what created from what we saw was the Arpanet to the World Wide Web, and which now we know HTML, URIs, especially HTML. This is part of all our lives. In fact, I'm looking at it over the web here. So this is really the foundation for what we know as our internet. So this is from the World Wide Web Foundation. Definitely take a look at it. It's pretty fascinating stuff. In any case, this also brings up HTML, our first thing called a protocol. So in any case, what is a protocol? Well, a protocol is a set of rules for talking. So we just saw that based on Tim Berners-Lee work. We want a way to, we need to be able to talk the same language. So an example would be if we had Sun Solaris had their own web rule set, and then Microsoft had their own web rule set, and Apple had their own web rule set. You can imagine the issues you would arise with trying to share information over a worldwide network. So protocols were put into place as a way to help sort of standardize this. So we have many protocols, but there are two core ones here. So first one being TCP/IP, and then we have IP. So TCP/IP work together, but they're actually two separate protocols. So you'll see TCP/IP, TCP/IP sort of put together. But think of it this way: IP gives you your IP address. So IP works with addressing and routing. So we saw before how do I get information from A to B the best fashion, the quickest way, and most reliable way. TCP deals with how the information gets broken up into packets and sent from A to B. So this deals with how stuff is communicated and sort of broken down. Think of it this way: when you go to the eLearn website, you don't get the entire eLearn web page sent in one large chunk. It gets broken into what's called packets. Almost like when you order furniture from, let's say, a furniture company like IKEA. You don't get the desk delivered complete. It needs to be. It comes in boxes. So box, 1 of 10, 2 of 10, 3 of 10 will arrive. Each box is inspected. It has a to and from on it, labels. So our shipping labels, which of course this handles this. The addressing is this, but how it's broken into boxes is this. And this also takes that desk, per se, and takes those boxes, unwraps them, opens them up, and puts the pieces together for you. So in the end, you get the eLearn web page, but it comes across in small chunks. So TCP covers the chunks, IP covers the address labels that go on those. All right. So I just covered that already. Again, you'll see this in the slide. So this is addressing. So how addressing works. So yeah, you'll see this before. You might see this here. Ipv4 is going to be on the way out. There's two versions of IP addressing: Ipv4 and Ipv6. And you can imagine 4 is older, 6 is newer. 6 has many more addresses. It has a lot of them. It handles mobile devices better. Ipv4 and 6 both do this. There's ways to do this, but in any case, Ipv6 is newer, but to be honest, Ipv4 is still around, and we're going to see Ipv version 4 here in our demonstrations. So again, IP address is basically your address on the network. So how this works, let's take a look at Ipv4 address. So here we have an Ipv4 address, and on it we can see, let's get a little longer here. It is basically binary. It is a 0 to 255 range for each of these dotted decimal formats here. So you can see this is broken into binary, which you don't need to worry about too much right now, but understand there's 4 of these notations here. And usually, and we're going to talk in the context of a home address. There's something called a netmask we'll talk about in a second. But what a netmask does is it says, this is my network, and this is my host. So if you had a home network, let's say your laptop is on .1, and your phone gets .2, and .3 goes to your desktop, and .4 goes to your Amazon Alexa, and so on. Up to 254 hosts. Now I know it's 255, but there's always one reserved for like a network router. Almost like the router you get brought in from like Spectrum or AT&T. That has to have its own address. It'll either be the top end or the lower end of that. It might be 255 or it might be .1. In any case, there's always one reserved for that. So you have up to 254 hosts or devices. Now this can change, and we'll talk about that when we talk about netmasks. But that's basically how IP addresses work. So let's look at it here. So Subnet Mask. We'll talk about what this is. Again, this is applied to the IP address. This is going to tell us what part of it is the network and what part is the host. Now, normally you have a unique IP address for each internet device. Now, that's an important aspect, internet device, because here on my home network, I have several devices, but not all of them are actually on the internet. They're all within my own subnet, my own private network, which is my home network. And same with yours if you have one at home or at school. This is called subnetting. It's actually, even this breaks it even further. With the subnetting, you could have like a building. In that building, you could have a main network and a subnet for each classroom. Each classroom then has several computers inside of it. Each one of these is a separate subnet. And the reason why you do this is for many reasons. One, of course, being convenience. I could take down a classroom and not take down the whole entire building. Management. Again, I can manage computers on the network. If I need to make custom changes, I do it to that one network. And also security. It's used. You can use with routing. I can say certain networks cannot access certain subnets, or certain devices can only access certain subnets. So that's a lot of reasons why you want to have subnets set up, and Subnet Masks take care of that. So we'll take a look at that in a second here. But again, it's really out of order. We're going to look at this actually live here. So Ipv4 addresses. Again, these are 32-bit addresses, as we saw. So I got it up here. So this is a 32-bit address. So that means it has a max of 4.3 billion possible IP addresses. Now, again, this is called a dotted decimal format. This is probably what you would probably see at home, 192.168.1.134. This is real common for a home network. Again, each dotted decimal here, or each octet is a 0 to 255. Now, I'm not sure this is true or not, but the thing is 4.3 billion. Well, back when this was made up here, when we saw Arpanet in the 60s and 70s, that seemed like an incredible amount of devices. There's no way we'd reach that. Well, it has exploded. As we know, the internet is encompassing the entire world, and there's more and more devices that are hanging out on the public web. Web servers, API servers, database servers, for shopping, convenience, everything. Our whole entire lives are on there, and we actually hit the 4.3 billion mark and ran out. Now, supposedly in February 1st, 2011, that's happened. Well, in reality, you had several companies like IBM, Intel, these large corporations. They had huge blocks of Ipv4 addresses. They would, back in the day, they would get 200-300 blocks of them, and they could just hold on to them. They did release some, but it did get to the point where it was running out. And this is where Ipv6 came in. Look at this here. Ipv6, let's talk about it. It is a 128-bit addressing. So here's Ipv6 versus Ipv4. So it uses something called hexadecimal. Hexadecimal is a way different format than a regular decimal. Decimal, of course, we know that as 0 through 9, right? a decimal place here. Hexadecimal is 0 through 9, and then A through F. So that's why you see, and this is a dot notation. This is actually has a notation with colons here. So this is 128-bit. It is very large. It is, man, I had to look it up. It is huge. It's like you can have billions reserved just for individual network. So I'm not going to go into how this breaks down here. Other classes will go into how this gets formatted. But this is an IPv6 address. How it's made is way different. How you work with it on the internet is way different. And how it gets assigned to individual devices is also a little different. Part of this back here becomes the MAC address of the device, and then the router stamp and the network. Let's look to the book for the specifics, but there are other courses where you'll break down this. Now this is supposed to take over everything, but in reality, this is still around. This is a lot more complex. Now this is on the internet. A lot of major devices now, such as internet backbone routers, major internet devices all use IPv6. It is out there, and actually all OSs do support it now. Windows 10, Mac, Linux, mobile devices all support IPv6. But in reality, when it comes to home addressing, when Spectrum comes to your home and sets up a router, you're going to see this. So in case, take a look at this, and we'll see where we set it up. All right, there you go. So 128-bit addressing. These are called hexdits. There are 8 groups of hexadecimal numbers separated by colons. And then the slide here, and this from the textbook, gives you an example how it looks. So the reason why both these are important to understand is how this works is where you get the address from. Well, if it's a home address, there is a protocol, type of protocols already. A protocol being, example, HTTP. Well, there's another protocol called Dhcp. And it runs on everything, many devices. Dhcp will run on your devices such as your home router. Switches might have them, things like that. So those home routers you get from Spectrum have their own Dhcp server. When you turn a device on, it calls out and says, "Hey, can I come on the network?" It says, "Sure you can. Here's the stuff you need, including your IP address." And it's good for 24 hours. So that's the private addressing. Now, public's a lot different now. You can imagine a private address, I have .1. Maybe 24 hours later, my device goes back out and says, "Hey, can I stay on the network?" "Sure, but I need to give you .2 now." So now you have .2. Now the operating system handles this for us, and you'll see the settings for this here in a second in Windows 10. You can set this, of course, as static. This is referred to as a static address. This is referred to as a dynamic address. Most of the time, it is hands-off. But you can imagine if you're a public-facing company, you don't want your web server, you don't want eLearn, you don't want your commerce site to have their IP address changed, because that changes your something called Dns Records. DNS is like our phone book of the internet. It is also a protocol, by the way. So one of the common protocols is DNS. So this gets something called stack addresses, and this is actually assigned by the IANA. So this ties back to IP address ranges, of course, that we saw they were bought up back in the day. So who owns what IP address and so on. So because we have these different IP addresses, there are different ranges. What you have here is a class A, B, and C. Think of class A here. The 10 dot to the 10 dot stuff typically is like internet devices, backbone routers, things like that. The 172 these are maybe internet-facing devices on corporations. Now this, of course, can overlap, so don't take this as exactly the dividing line. But these could be corporate-owned devices or servers. And then the 192.168, this is called Class C. This is your home-based stuff, or NAT, or local networks. So again, we have DHCP, which is a protocol. This will give us our address automatically. Otherwise, you get assigned an address from the the IANA for stack addressing. All right, so all these addresses, IP addresses and so on, there's some really important ones. Here's this pretty critical. These are really the four main things you need to come away from this chapter with. These are the things you need to connect to the network. So again, usually when you turn, let's say you walk home, you come home, turn your phone connects to your home Wi-Fi, and it says, hey, can I connect? It says, sure. You've been authenticated. You have a passcode typically. Your passcode was correct before, it's still correct again. Welcome back. Here is your IP address, Subnet Mask, Gateway, and Dns Server. Now what are these? So IP address, again, this is this address here, as we saw, like 192.168. You're .1 on the network, or we're .10, let's say. Subnet Mask, we'll look at this in a second. This is good to note. From this, again, what part of this, it tells the operating system and the router what part is the network and what part is the host. So they go hand in hand. Every time you get an IP address, you should get a subnet mask. Default gateway. This is your router. So typically it'll be the same as your router, but in large corporations it might not. Your Dhcp server could be separate from your router. So you can see where like an institution like Sinclair, you don't want everything on one device, where your home network, everything, your router, your gateway, and your DNS server are all that box that were provided by Spectrum. In any case, if you don't have a default gateway, you can't get out to the internet. DNS server, so DNS, Domain Name Service. This is the phone book of the internet. It's a little more complex than it sounds, but it is based on the actual .dot in .com. That is the root domain called. This is the dot. And then you have .coms, .orgs, .biz, .mil, .gov, and so on. So this smart phone book of the internet, it has cache, a lot of caches, even down to your operating system itself. So when you type in google.com on the web browser, it knows where to go. It knows that google.com has a certain IP address to talk to. The IP address then gets routed through your router. You find you the best connection, and you can then use TCP/IP to send packets back and forth. So these are the main things you need to have. So let's take a look at where we get these from. And we'll take a look at this in Windows 10. And we'll take a look at it in the context of this lab. This is this week's lab. I'm not going to go with the questions. You can answer those pretty much. These are basically, we'll look, there's commands for this right here. We'll see the commands for this in a second. IP address ranges. Well, we saw that on the slide. Explain what DNS Server does, but here we go. So configure TCP/IP in Windows for these things here: your DNS, your gateway, Netmask, and your IP address. So again, NetLab itself, a big note here, it doesn't have any kind of internet access, so it really won't work, but you can still set it up. So we are in Windows 10. We're in Control Panel, Network and Internet, Network and Sharing Center. So the important aspect, of course, about your device is your actual connection. And that is it Wi-Fi? Is it an Ethernet device being plugged in? In this case, this desktop here has an Ethernet device. If I click on that, you see the status. If I click Details, you can see the IP address. Now, this is called the auto configuration IP address. This is normal because computers can't operate with an IP address. They sort of freak out. TCP is inherently built into operating systems now. It is very much core of the system. And you need a local IP address. Actually, a lot of times applications will use TCP/IP to talk, or TCP protocol to talk between apps. So it's very common. It's a common way to talk. It's called through sockets. In any case, you'll see one it's auto configuration, so it's given one automatically. You can see there is a subnet mask also given automatically. But you see notice the default gateway, DNS are all blank. So again, the idea is we want to see the properties of this. here we see our properties. Now you'll see it's in the textbook too. You see there's TCP IP version 6. We're not going to touch that here in this demonstration, but we look at TCP IP version 4. So the checkbox indicates it is on and is being used. Again, this is Windows, so properties. And you can see here it is set to use called DHCP, which is obtain everything automatically. So again, since there's no network here in NetLab, there's nothing to there's no one to talk to get that information from. So what I can do is I can set it manually. So 172.16.1.2 Subnet Mask. You can see it, now I did part of it automatically. There's a calculation how this is done. So the OS knows this and set it for us. And our default gateway is 172. That's actually supposed to be 16. 16. You can see it's on the same network, 16.1.1. So again, remember our gateway server. This is our device that usually gives us access to the internet. You can see here we're .2 and it is .1. It is on the same network though. When you get more advanced networking, there might be ways to have a different gateway IP address than your IP address, but normally these have to be on the same network to work. DNS, you usually have up to 2 or 3. 172.16.1.254, and in this case only one. That's it. Now if I look at the status, I close this, look at the details, you can see now it is configured. So that's where you get your internet details here, and you can see here that is set up. Let's go back to our slides here. So the book talks about how this works with the subnet mask. Think of a subnet mask with a 255. The ones tell it what's reserved, the zeros tell it what part is for the host. So 255.255.255 tells it that the first 3 octets is the network and the last octet is the host ID. Now this can change based on the network, but come away with that, and that's all you need to know about Netmask. So let's see if we can view configuration. Let's look at some commands. Now there's a lot of commands we can use to troubleshoot our stuff here. Now we'll see this here. This is actually our NetLab. Ipconfig, Traceroute, ping, and Nslookup. Now I said use your version of Windows. If you have Mac, I have Mac here, you'll see how I do it on Mac. These commands, they work on everything. Again, don't do this in NetLab, it won't work. And also these are the same commands we use here for this question. So both identify your computer and destination computer on the network, operate, they can successfully communicate. So how can we see if 2 things communicate correctly? So first off, let's look at our configuration. That's ipconfig. So see here, ipconfig, and you can see there's actually my network I set up. Now there's also ipconfig switch all. Gives you a little more information. Here we can see the physical address. This is called our MAC address. This is also hexadecimal. This is for the physical device, so a Wi-Fi card, a network card. This is a worldwide unique. Part of it is a unique identifier, and the other part determines the make and model of the device. You can see here we have our Dns Server, and we have our gateway, Subnet Mask, Ipv4 Address. So ipconfig is a great way to go ahead and get information, because when it comes to troubleshooting, one of the first things you got to do is gather information about your configuration. So that's ipconfig. Now we'll look at these last few commands here. We're going to go in a little different order. Look at ping. Now ping won't work here, so I'm actually going to go to Mac. Now Mac has something called network utility, and also show you in the command line. You can see here my IP address, my hardware address, ping. So I ping google.com, ping is a packet that uses a protocol called ICMP protocol. We can also launch this from terminal. I can ping either a IP address or a domain. Now this one times out because Sinclair is known to block ping, and that's not uncommon. So a ping is, hey, are you there? And then, are you there, Sinclair? And Sinclair will reply back, yes, I'm here. Now, again, it's not uncommon for some networks to block this. Ping can be used in malicious ways. So you have what's called packet loss. So two aspects of ping. So you can see I ping Google. Let's do it over here too. So you can see it work here. Now Google will go and let me ping. I'll do Control-C here at the command prompt to stop it. You can see there's a few stats here. One, of course, is packet loss. And we also have something called the round trip time. It's usually in milliseconds. So you can see here 13 milliseconds, 12 milliseconds, so on. High ping and ping loss. Packet loss is bad. That means there's routing problems. And a large round trip time is called latency. And if you're any kind of gamer, you know latency equals lag, and lag is bad. So it's a good way to test for latency. That's called ping. You can do this also in the command line here. It would be ping google.com. Again, it won't work here. You can see in the NetLab, it will time out. Control-C should stop it. You can do the same thing in Windows. So that is going to be tell us, hey, are you there? Can I communicate with you? Yes, I can. If I get a ping back, I can talk to it. Now, how to figure out how I got there? So again, we have a thing called Traceroute. Now, Traceroute, again, you remember our routing diagram. Routing is, you don't go straight from your computer to Google or to eLearn. You go through several hops or several routers. This is called routing. This goes back to Arpanet. There are several ways to get to one place. So you can see I did a round trip or trace route on google.com. You can see my home address. This is my home router, 192.168.1.1. You can see my my ISP, and they went through there in Inglewood, a .NET, Donet, which is their sort of their hub. And from there, it goes off the internet. And this is a router here. There's this router here, or this company. I'm not sure this is. Cincinnati Level 3, they're a huge internet provider, and then this was blocked, hence nothing was given back. And it bounced off of this IP address here, and this here, and this here, and so on. So then I got to what would be the first hint of Google. So in any case, that's how I got to Google. That's called Traceroute. In Windows, if you do it in Windows, and it's fine, it's called Traceroute, Traceroute, google.com. Again, it won't work in network. Do this on your home Windows system if you have it. You got Control-C to stop it. It won't work here in NetLab. But if you can do it and run Traceroute, if you're on Linux or on Mac, you can do Traceroute. It's Traceroute. So Windows is Traceroute. And in Linux and Mac, it's Traceroute. So, and you can see here it's bouncing again. It's probably looks different from the last time I ran it. And if you're really curious, I'll have it installed. So let's see. We'll let that run. I don't think I have it installed anymore. I used to have something called Visual Traceroute. Yeah, there's actually something called Visual Traceroute. See, I have a copy of it. I can show you a link to it. That'll be in the slideshow, actually. But you can actually figure out where these IP addresses. You can get a latitude, longitude, and actually see where this server is at. So Traceroute. So ping, can I talk to you? Traceroute, how do I get to you? Ipconfig. And Linux and Mac, it's Ifconfig. So you see Ipconfig, and here it sort of shows up in the info packet here. So Ipconfig in Windows, Ifconfig in Mac and Linux. Now Nslookup, our last one. So again, Traceroute. Nslookup, who has Sinclair EDU? So that's called Nslookup. Also called whois. Whois is an older command, but again, if I do whois on Sinclair EDU, it says, well, Sinclair has, this is who their domain provider is. ICANN gave it to them. Here's their name server. This is their DNS server. And they have the IP address here of registry domain. Oh, yeah, so EDU. Oh, the register through URL. So information about who owns it. That's what whois does. Let's look at Nslookup here. Nslookup. That whois is an older one. There you go. So Nslookup, and this is the same command in Linux and in Linux, and same command in Windows. Who owns it? Sinclair is at 140.106.57. So that tells me who owns that IP address. Same with Google.com. Now you can imagine Google.com does not have one IP address. Neither does Sinclair. They have many of them. So what you have is you have the one that you were given to use. There are ways you can use Dig. You can get into and figure out all the IP addresses. You can imagine Google's got a lot of them. But when I talk to Google, this is who I'm talking to, this IP address. And this goes through my DNS server. So again, Traceroute. But who owns the IP address? Sinclair, that's Nslookup. And then this last command here, we saw this already, it's Ipconfig. And we saw it here, and of course that does run here in NetLab. That will work in NetLab. So that is your commands to help you troubleshoot. And here you can see how it looks here in this slide. Linux looks like this, or Mac and Linux looks a little different, but it's the same information. Here's Linux. So ideas, you can figure out your Netmask IP address, your MAC address, and so on. A lot of times you'll see this address a lot, 127.0.0.1. This comes up a lot. This is called a local loopback or local host address. Almost every host needs this. It's a way for it to talk to itself. So I'm not going to get into a few things here. ISPs, we know about that. We're not going to talk about this. Wi-Fi, probably the one standard you're used to, the 802.11 standard. We know typically it does not connect directly to an ISP. It uses some sort of wide area network or wireless area network or a WAN. Your home has one probably. Sinclair's got them. Your libraries have them. Schools have them. There are ways to talk securely over this. It's called a VPN. What you do is you create a private connection through a VPN company. So like I can open up this here, and with CyberGhost, sort of automatically select a country, or I can connect through a different country. So VPNs, you can find out about that too in the textbook. This is great really for mobile devices. So if I'm traveling and I get to a public Wi-Fi and I'm not secure, I'm not sure the security of it, I can use a mobile VPN and connect to a VPN and then talk to my bank or my email, and it protects the traffic. So, and the rest of this we know about common client stuff. I'm not gonna go over this. And we have sharing. All right. Most of sharing was turned off. And that should cover most of the chapter. I believe we are good here. So yeah, let's get the rest of the questions here. Recent browsing history. I think web browser is the one thing we know how to use. So if you come up from the chapter, come on understanding these aspects, what an IP address is, especially IPv4, and the difference between IPv6 and IPv4, with IP, what a netmask is, just generally what it is, what a gateway and what DNS is. And these commands, Ipconfig, Traceroute, ping, and Nslookup, what they give us, and they basically give you the answers for these right here. So keep those in mind. You can use your home system for most of this too, and you can use NetLab for this 10.3 like you saw me do. So anyways, hope that covers most of the aspects. Have a good rest of the week. Thank you.